Codemotion.
Thanks for coming today. This is talk about languages, talk about Objective-C, and specifically about Objective-C for Java developers or for someone who is coming from Java. Okay. So first of all, a few words about me. I'm working at a company called Young Culture. It's a Swiss-based company, and we are actually present in Switzerland, Germany, Austria, and Serbia, and we are developing software for various companies. I have something like 10 years of software experience, or maybe a few years more than that, and the last couple of years I also do a lot of mobile development. So first I started with some Android development, and then I tried out some Objective-C and iOS stuff. And yeah, this is a language talk. So before we start, a bit of disclaimer that I'm actually a mostly Java developer, and I really love doing Java stuff. So if if there is some Apple fanboy here, don't mind my bias towards Java. Okay. And one thing before we start, that would be nice to do some head counting. So can you raise your hand who knows Java? Who is developing some Java? Okay, cool. And who is developing Objective-C? Who does Objective-C? Yeah, as expected, a smaller crowd. And one last question. Okay, who loves Java? Who loves developing Java? Haha. Okay, groovy, cool. So this is the agenda of today's talk. We will, for all of you who do Java, you will have a crash course into Objective-C syntax. You will see some examples how to make a simple Objective-C stuff. Again, keep in mind that this is language talk. I'm not trying to tell you how to make the next best iOS app or how to make some money on Apple Store. This is just how to use the language itself. After that, we'll talk a little bit about memory management, because for Objective-C and for Java developers coming to Objective-C, this is, I think, the biggest pain point. After that, we'll cover some object-oriented concepts of Objective-C, or lack of those, and finally we will see some good parts, some good things about Objective-C, and of course some sort of conclusion. And before we dig into examples, into code, let's examine the motivation for this talk. I work as a developer for a really long time, and the most important thing that we all want to do is to make quality software, right? We want to make a good quality software. The last thing that you want is to fix some bugs late at night, catching up on some deadlines. So in Java is a really good language to produce a really good quality code. And if you jump into Objective-C just like that, the quality may suffer. So this talk is intended to tell you how to ease that pain, how to actually make a good quality code, how to try to make a good quality code in Objective-C. Okay, and the rest of the talk will basically be just going through some examples in Xcode. So okay, let's get started. First, let's open up Xcode. Let's start easy. Let's create a simple. Do you see it? Okay, letters are okay. Okay, cool. Let's create some sample project. Let's code it. Codemotion. Example 1. To see some basic syntax. Okay. Just for the sake of simplicity, I will delete the existing stuff. So okay, this is the Xcode. This is the IDE for Objective-C developers. And okay, let's try with hello world. Let's declare some variable. Oh. And let's print it out. Okay. Sounds good so far. Let's try to run. And here in the output, you can see the hello, right? So this is sort of first Objective-C program that you may make. But there are, of course, a couple of issues with this example. First of all, this is not Objective-C at all. Okay. If you look at that, you have some main function that's entry point. If you know C, you will recognize this instantly. Then you declare something, and then you invoke another function, which is not a member of any class. You don't see any kind of class, anything. There is no object-oriented stuff here at all. So this is like the first big point of this talk, that Objective-C is actually, unlike Java, where people made a clean cut and made an entire language from scratch. Objective-C is just extension over good old C. So you can mix C and Objective-C code even in the same file. To emphasize this, you can make something like void. Hello. You can make something like this. And this stuff will still work. You know, you still produce results, though you do produce some warnings from compiler. But basically, you can just type in some C-style stuff in any Objective-C program. The only thing that is actually Objective-C in this example is this NSString. NSString is a string class, something like a Java string type. With this difference that in Objective-C, everything is prefixed with this prefixes like NS. NS actually stands for next step. And if you know the history of Apple and history of OS X and iOS, then you know that everything came from the company called Next Step. A lot of code came from there. And this heritage also shows everywhere. But also, this is the point, there is a good point here that everything that in Objective-C you actually do not have namespaces, you do not have a way to separate your class names or your method or your classes. So you need to prefix them somehow to avoid collision. If they just call the class string and you make some string of your own, then you would end up with name collision. So everything is somehow needs to be prefixed with some prefix. Okay. So okay, let's create a class to see how it actually works. Go new file, Objective-C class. Let's call it like this. Okay. Okay, and here it is. This is the first Objective-C class that you may make. And first thing that you will see that, like in C, you have header files, .h, and you have actually implementations separated in different file. Also, you may notice that the words are somewhat different. Instead of class, there is interface, and as a Java developer, what you know as interface is called protocol in the Objective-C. Okay. Let's make some simple method. This plus denotes that it's a static method. We are making static method which will return string. Okay. So this is how you define methods in Objective-C. Pretty easy. Okay. And if you want some parameters added to that, let's do that. Let's make another version. This is the way how you actually define methods in Objective-C. How you declare them. So there is a plus for static, minus for instance methods, then the return type, method name, and optionally after that come some parameters. Now we have to implement them. Let's make something simple, like yeah, sure. Better? Do you want like this? Okay, cool. Hello. And the other one. Now here we will do some actual Objective-C development. We will say return, but we will make it like this as string alloc. This is the syntax for method invocation in Objective-C. You put the square brackets around the method call. Okay. Init with format. Hello. %at. Name. Family name. And you can actually chain the invocations. So for example, AnaString alloc returns an instance of AnaString, and then you call init with format on that instance, and after that you return that instance to caller, the one who invoked that. So let's see here how we invoke this. Let's do import. CM message. As you can see, I chose this CM prefix like Codemotion for my namespace, sort of namespace in this case. Okay. So here we'll just replace this like CM message, new message with name, code, family name. Motion. Oh, crud. Okay. We will just also do it like this, just to get rid of this compiler warning. Okay. This is a proper way how to use anaslog. Let's try to run this. So it works, you know. You have the result. Okay, so this was just the basic intro how you do things in Objective-C to get you some kind of feel how the Objective-C code looks like. Some things that I would point out here is that first of all you mix C and Objective-C within the same file, within the same project. There is really no difference because Objective-C is just some sort of extension over C. The other thing that you might want to know that this star pointer, which at this point, if you learned some C or C++ stuff, this might give you a bit of feeling that in Objective-C you really have to take care about memory. That memory management is not so easy as in Java. This star basically tells you, even at this point, that memory is kind of an issue, that's something that you really have to take care about in Objective-C a lot. So having said that, I will show you a little tool in Xcode, which is kind of great, tool for analysis of your program. This is a simple program. It has just like 10 lines of code or something, I don't know, 5 lines. But still, even for such small program, you can analyze it, and you can find out potential problems. The analysis tool can tell you the problems within your program. And yes, it found something. It found a memory leak. Even in so small program, you actually can, and in this case, we do leak memory. And it happens because of this. Here, we allocate string, like in Java, you instantiate something, you make instance of string, but after that, we do not release it back. In Java, garbage collector does that stuff. It collects every bits and pieces of unused memory, and it somehow magically erases that from memory, but in Objective-C, you have to do that yourself. So for every allocation, like for every alloc, you have to dealloc. So let's just try to do that. This should be okay now, right? Let's try to analyze again. And now we end up with another problem. It warns us that we should never deallocate, that deallocating is a mistake. So at this point, if you do not deallocate, it will warn you. If you do deallocate, it will warn you again. Like, somewhat crazy. Instead of dealloc should never be invoked, but instead you should use release. Let's try to see if this works. Analyze. Yeah, finally we got rid of everything. So one thing about memory management in Objective-C is that you actually have to do it manually. There is no there was no, until recently, automated mechanism how to do this automatically. So you have to manually deal with allocations and deallocations. And to make things worse, Apple tried to help you with this. So they made up some really elaborate scheme how to manage memory. So they say like this: every time when you call alloc, or when you call retain, or when you call a method which starts with new or copy, the reference count for that object increases by 1, and you become owner of that object. So every object comes with something called reference counter, which is called retain count, which basically tells you how many methods use that object, or how much that object is used throughout your code. And for every time when you invoke alloc or retain or something like that, the counter increases by 1, and every time you call release, it decreases by 1. Okay? So that's known as a concept of object ownership in Objective-C. So here, what we basically did with alloc, that we did one alloc, and this message reference count got increased by 1, and here in release, it got decreased by 1. Right? Nice and easy. Let's see if that's the case, indeed. Let's put some debug statements here, like this. We don't need this anymore, actually. Let's try to run this. And as you can see, after we allocated, the retain count is 1. Okay? So after we release it, the retain count should be 0, right? So do you have any idea what will actually be the value of, what will this line print? Do you have any guess? Do you think, how many of you think it will be 0? Like, come on. 0? How many of you think that it will throw some kind of exception? Yeah, because you did release one line before, so it might be exception, right? Let's try. How of you think that it may be something else? Ah, that's also a possibility. Let's see what happens. Yeah, it's some billions and billions and billions. At this point, my answer actually would be no idea what will print out. So what happened here? Okay. First line is pretty straightforward. You allocated an object. It has a reference counter set to 1. You print it out, and it's just as expected. It's 1. Then you release your object in this line. Okay. And after that, my guess would be, 0 because you decreased, or some sort of exception because this method after releasing is this object is no longer valid. But what actually happens is that this message object, this pointer to message, still points to something. God knows what, and it will print out something random at that point. You can actually do stuff like that in, message, uppercase string. You can still invoke methods, but they will do some random things. Sometimes it will crash. Sometimes it will just print out random stuff. Nobody knows. So the thing in Objective-C is that you really have to be careful about allocating and deallocating memory. Not only that you keep the reference counters in place, that you keep them synchronized with retains releases, allocates releases, but also once you release your objects, you have to be very careful not to invoke them anymore because they point to something else. That memory where this message was, in next second it may point to something totally different, and you can still invoke methods on that. And of course, the app will crash all the time. And as quick fix, you can always think in your head like, okay, I can do this. I can always make sure that I will deallocate. But let's see how this works out for us. In this case, it somehow magically worked out. But in general, this will also produce app crashes because these releases will also be invoked on God knows what. In this specific case, in this specifically simple case, it's somewhat okay, but in general case, it may turn to be a disaster. So you should never ever do this. You always have to keep not too many releases, not too little, but always spot on. Make the synchronized stuff. Does this sound hard or complicated? Because for me it totally does. Like coming from Java and having to deal with all these memory bits and pieces is for me totally painful. Let's try to do another example. Let me show you something about, this is maybe more interesting. Let's see something about object-oriented stuff in Objective-C, how Objective-C deals with object-oriented concepts. And for that, let's make a class. Okay, we can call it Let's make it a dummy class. Okay, here we are. So we have 2 files again, and for starters, let us make some. This time we will make instance method. Do something. Okay. Let's invoke that in our main file. Dummy equals allocate and init. By the way, these 2 calls alloc and init always go hand by hand. You in general in Objective-C, when you allocate, it will always have to be followed by init to actually invoke something like a constructing object in Java. But in Objective-C, you do that in 2 steps. First allocate, and then invoke a constructor in a separate line. Let's say like dummy do something. Okay, let's run this stuff, see what happens. Huh. It crashes. Program received blah, blah, blah. It will crash every time. So why does this crash? Because, let's stop this. It crashes because we declared method, but we did not implement it. Okay, in Objective-C, that's actually possible. You can declare a method and you don't have to implement it. It will compile, it will run. First time you try to invoke method, it will fail at runtime. So it's, you always have to remember this. And this is a real problem because, there's something. Now when we run this program, it will print out. It will actually work. You see, now it works. You have to really be careful about this because many times you can maybe spot some typo and you try to correct this, and now things will fail again because like this, and do something nice. Now things will fail again because we are again not synchronized. We did not implement this change in method name. So this is something that you really always have to keep an eye on. Good thing is that the tools will always warn you about this, and this is another major point that I want to make. In Java, we tend to ignore compile warnings. Well, it warns us about this and that, but in Objective-C, you really have to be careful about this. You always have to keep in mind that warnings do mean something, that they actually do mean something. Now let's try some other nice stuff in Objective-C. Let's create some properties. Okay. So this is the property declaration syntax. You just type property, then some sort of modifiers, which we will not go into. We will not go into that deep, and then you just property type and the property name itself. Of course, when you do that, you also have to implement the property, and you do that by synthesizing that. We call that property message. Okay, you always also like for methods, you do not have to do that. It will, it will go ahead and compile, but even when you try to access it, it will crash at runtime. So now, if you want to make a private method or a private property or a protected method or protected property, you will find out that you actually cannot do that. There are no access modifiers whatsoever in Objective-C. Simply no, cannot do that. Everything must be public. This method here is public. It's declared in header file, and the entire system sees every method, everything. You can do some sort of workaround. For example, you can implement method, and you can call it, let's call it secret method. I did something secret. And you do not declare that in header file. So this is sort of private, right? Okay, it's not declared. If you go and try to invoke, dummy, secret, there is no code complete, so somehow it's hidden from you. But if I know the method name, I can go ahead and I can still invoke this. It is private, sort of, because you do not have autocomplete, but still nothing prevents you to actually invoke that method. Nothing prevents you to call that method. This is a huge problem. The problem is so big that if you try to put app on App Store, Apple will actually kick you out because if you use some private APIs, some Apple private APIs. They protect it by not publishing your app. Because if you use the things that are meant to be private, in next versions, nobody can guarantee that it will actually stay. It's like, if you don't hide implementation details in Java, it's sort of like a bad thing will happen. And one last thing that you can do with the class, which is kind of nice, is that you can, declare some fields. And this is really cool. For fields, you do have private. Yeah, I know. Protected and public. So fields can be protected, but methods and properties, nope. Cool, huh? And this is actually working. Let's call this just for a private field, protected field, and public field. And if you try to let's try to access these fields just to make sure. And let's say dummy. This is not the way to do that. You cannot do it like this. Let's try like this. Nope. You have a special syntax for accessing fields, and you have a special syntax for method calls, and also you have a special syntax for property access. For property, it's like this, dummy.message. So you have three syntax rules how to access elements of your class. For method calls, for method invocation, you do square brackets. For the properties, you do like dot operator, and for fields, you do this arrow operator. So it's kind of messy, but yeah, it works. It shows that the language itself was never redesigned from scratch, but rather, it was built upon one feature upon another feature, and that shows in these syntax bits that where you actually do not have clear rules how to do things. And one other thing about object orientation in Objective-C, there is no way to make abstract class. Simple as that. You do not have abstract keyword whatsoever. You do not have mechanism to make abstractions. You do not have mechanism to make some, abstract hierarchies, which for Java developers, at least for me, is kind of unimaginable. We know so many tricks in Java how to make good systems based on abstraction, how to make good systems based on making the class hierarchies. In Objective-C, all those strategies simply fail because you do not have ways how to achieve that. You do not have one thing that I would also like to say that a few months ago, in last versions of Xcode and in last versions of SDK and everything, we got something that's called automatic reference counter, which is actually a mechanism to do some sort of automatic memory management where all this pain is gone, where you do not have to take care about retain, release, alloc, deallocs. The automated reference counter do that for you, but still there is a lot of legacy code, especially in third-party libraries that do not use the automated reference counting yet. So at least for a while, you will have to be aware and you will have to keep an eye on this stuff. And because this guy is totally killing me with time, we will. Okay. We'll just skim through the good parts, but because there are indeed good parts in Objective-C, like in any language, I found that there are some features of Objective-C that are totally cool and that I am really missing them in Java. First, and the coolest of all, is there is no null pointer exception. No, you simply do not have null pointer exceptions. If you invoke method on a null object, it will fail silently. It will just do nothing. If you access some property, like type anything on a null reference, it will just fail silently and in a predictable way. If you try to access integer field, it will fail by returning 0. If you access a string field, it will fail by returning the empty string, something that you would really expect. So that's like totally great stuff. If you ever did some JavaFX stuff, JavaFX actually had this JavaFX script. It actually had the same concept built in, but in Java it would fail miserably every time. The other thing that I really like about Objective-C that functions are first-class citizens. Okay, you can pass function as the argument, as a parameter to a method call. So you can actually pass functions around just as you passed integers and strings in Java. So that's like, totally cool stuff. Also, categories. Categories is a great mechanism to extend the class without inheriting that class or without any intrusion to that class whatsoever. You just make a category, even an existing class like NSString, for example. You can extend behavior of NSString by, let's say, making your custom methods to validate phone numbers or emails or stuff like that. You put that into category, and string behaves as it behaved before, but you have those added methods. You have those added functionalities for your methods as well as for all the methods from the framework or everything that is embedded in the APIs. Also, the protocols. As I said, the protocol, that's the interface in Java. You define some protocol, but in Objective-C, you are not obliged to implement every method of the protocol. You have the @optional keyword, which actually tells the compiler not to care about that you do not do not want to implement optional methods. So that's like something totally cool. I am sure that every one of you has seen some interfaces in Java which are like, you know, this big, and implemented them by doing some dummy implementations just to satisfy the compiler. You know, I have seen that 1,000 times. In Objective-C, it's much more elegant. It's much, much better. And the last thing, the Apple framework is totally, totally cool. The APIs, the UI components, it's enjoyable to work with, okay? It's beautiful to work with. And especially for the UI, you can show, it shows that Apple is actually doing this stuff for 30 years, you know? Everything works perfectly, everything works as expected, and that's something that's like. And just a quick conclusion, or instead of conclusion, you know, you would probably want to ask me, do I need to mess with Objective-C at all? Is that, for me, the answer is, how can I know that, right? It's up to you. I would never build some server-side, you know, some big scalable server in Objective-C, but the iPhone app, yeah, every time. And piece of advice for the very end, understand compiler warnings in Objective-C very seriously, because they, in fact, do mean something. Unlike Java, the compiler, the tools tell you so much about your code, and you always have to respect that. Okay? Okay, thanks. That would be all from me. Thanks.
Codemotion.